Okay, class, we're going to talk about naming and writing acids, so compounds with acids in it. So far, we've looked at a system for naming and writing compounds that are called ionic compounds, where you have a metal and a nonmetal. And remember, we always name the cation followed by the anion. And if it's a transition metal, then we simply use the Roman numeral system. If it is a molecular compound, remember that's a nonmetal bonded to a nonmetal, then we use the whole system with the Greek prefixes and so forth. Now we're going to shift over. We're going to take a look at a system of naming acids. Now, the way you identify an acid in a formula is that it has H in the beginning of the formula, and then it's bonded with some sort of anion. Now, that anion can be a negative polyion. It could be a negative ion, okay, like a regular monatomic bromide, chloride, fluoride, or something like that. So here are a few examples of that. You have H bonded to an acetate. All right, so that would be an acid. All right, we have H2 bonded with a sulfate. We have H bonded with a nitrate anion. And then we have H here bonded with a bromide ion. So let's take a look at how we do this. This little table that you want to jot down in your notebook here, this table kind of summarizes the naming system that we use for acids. So go ahead and pause the video at this point right here and jot down this video, or excuse me, this table here in your notebook. Okay, so after pausing and the video and jotting this down in your notebook, what you do is you look at the anion. Remember, it's going to start with a hydrogen, and it's going to have an anion part to it. If the anion ends in IDE, then we add a prefix hydro, and then we have the stem, and then we have ic as a suffix on the end. And then we just simply add the word acid. We're going to take a look at some examples of these in just a minute. If the anion ends in an ITE, like a polyion, like a sulfite or chlorite, then we use the stem, and then we put the prefix OUS, and then the word acid. If the anion ends in ATE, like sulfate or chlorate or any of those, then we use the stem and we use IC. So now let's take a look at a few examples of this. And also, I want to share with you a little bit. Get over to a clean page. I want to share with you a little bit, a little kind of a saying that a student shared with me that might help you learn how to name acids. All right, the saying goes like this: Sprite is delicious. And you might just want to write this down first, and then I'll go back and explain it. Sprite is delicious. My ride is hydraulic. And then I ate something icky. All right, so well, what in the world are you drawing down there? Well, here's how it works. If the anion ends in an ITE, then that means that you add the stem and then you add OUS. If the anion ends in an IDE, then that means you add the prefix hydro and the suffix ic to the stem. If the anion ends in ATE, all right, then you're going to just add the prefix ic to it. So I thought that was a pretty nifty way of going through and using or remembering that little table. So whatever works for you, if this works, just memorize this. If the table works for you, then memorize that. Well, let's take a look at a few examples of this, all right? So let's first of all take HNO3. We're going to start off with the formula, and we're going to go to the name. What you first need to do is identify it as an acid. Well, you identify that because it does begin with H. So anytime you see an H, you need to be thinking that it's an acid. And then what you need to do is you need to say, well, what is this part right here? What is the anion part? Well, in the anion part, if you were just naming that, you would name it nitrate. Now, if you're not sure, then you just look at your polyatomic ion sheet that I gave you in class, and that'll help you with that. But hopefully you're beginning to remember some of these. Okay, so nitrate ends in what? It ends in ATE. So our system for ending in ATE means we take the stem, okay, nit, and then we add the ic part to it, nitric, and then the word acid. So this just becomes nitric acid. Well, let's take a look at another one. Let's say we have H3 and we have PO3, H3PO3. All right, again, we see the H in front of it. Don't worry about the subscript. That's just there so the charges will equal 0. And then we look at the PO3 portion of this. Well, what is the name of that polyion? Well, that would be phos. And how would it end? ITE. So that's phosphite. All right, so if it's an IT ending on it, then we use the stem and we put the OUS. So this becomes phosphorus because it comes from phosphorus. And we use OUS, phosphorus acid here. All right, so that one is a good example. Now let's take a look at HCN as another example of this. We look at the polyion here, and we see that this one right here is cyanide. All right, so you can tell that I'm still here at the school. So cyanide ends in what? IDE. So how is this one? Well, this one's a little different. We put the prefix hydro, and then we use the stem, cyan, and then we use IC. Hydrocyanic acid would be the way that this one is named. All right, so you kind of getting the idea of what we're doing here? Let's do a few more examples. All right, actually, let's go the other way. Let's go from the name to the formula. Let's suppose we have sulfuric acid. Okay, first of all, you're going from the name to the formula. So from the name to the formula, you need to look and say, well, what is put on this thing? Okay, what's put on the stem? So an ick is put on the stem. So what does that mean? Well, that means that it had to come from the polyion of sulfate. So what is the formula for sulfate? It is what? SO4 with a 2 negative charge. So for our formula, we're going to put down H because acids begin with H. All hydrogens have a 1 plus charge, or you can just put a plus. And then we're going to put down the formula for sulfate, SO4 2 negative. Now we're going to treat this just like we do any ionic compound. We have to make sure that our charges cancel out and equal to 0. Well, this is a 2 negative, so that means I need more positives. So I need another hydrogen added to this. So now we'd have 2 positives and 2 negatives to cancel out to 0. So the formula would become H2SO4, and that would be my final answer for that one. All right, let's take a look at another example here. Let's suppose we are going to say nitrous acid. Nitrous and then acid. Okay, so we see OUS. So what does that tell us? Well, that tells us it must come from nitrite. Nitrite, not nitrate, but nitrite. So what's the formula for nitrite? Well, that's NO2 with a negative charge, 1 negative charge. So let's put it with our hydrogen. We'll have H with a 1 plus charge. We have nitrate, NO2 with a 1 negative charge. And so a 1 positive and 1 negative will cancel out. So we just rewrite it without the charges. And HNO2 would be our answer for that one. All right, let's try another one. Hydrochloric acid. Hydrochloric acid. All right, so this time we have something else. We have this hydro prefix and the ick. So what does that tell us? Well, both of those together tells us that it has to end in IDE. So what stem with chlor ends in IDE? Well, that would have to be chloride. So what we have here is we have hydrogen, 1 plus charge. We have chloride, that is Cl. It's a group 17 element, so it's a 1 negative charge. And so a positive and negative cancels out. So we rewrite it without the charges, and we have simply HCl. All right, starting to get the hang of that. All right, let's see if we can get one more in here. Let's do perchloric acid, pure chloric acid. All right, so we see that IC again here. What does the IC tell us? All right, I need to put this up here because I'm running out of room. ICE tells us that this has to be perchlorate. Again, check your polyatomic ion list if you don't have this. So perchlorate, so we're going to have H with a positive. We're going to have perchlorate, well, that's ClO4 with a 1 negative. So what does this become? Well, it becomes HClO4, and the positive and negative cancels out, so we rewrite it without the charges, and now we have the formula. So remember the system for naming the acids. Sprite is delicious. My ride has hydraulics. I ate something icky. And you should be able to go from the formula to the name and the name to the formula. All right. Well, I'll see you in class. We're going to work plenty more examples. I'll answer any questions that you have, and we'll have lots of practice in class. All right. See you then.